Hello everyone, this is Ravi Kumar and once again I welcome you all on the platform of e-learning B.E.S.T, and today we are going to discuss some key points that, so what are those key points that we need to keep in our mind before solving the questions on the limits, right? So the first key point is limit exists at x equals to a if LHL is equals to RHL, right? We already have discussed about this thing when the limit at any point x equals to a exists if and only if the limit x tends to a minus fx is equals to limit x tends to a plus fx. We also call this value as left hand tendency and this value as right hand tendency. That is, left hand tendency and right hand tendency becomes equal, then we say that limit does exist at that point, right? The next point is we will calculate the limit when x tends to a fx is of indeterminate form, obviously, right? So when we need to calculate the limit, if x tends to a fx is in indeterminate form, right? If it is in determinate form, we have to directly substitute the value of x is equals to a in the given function, and we have to check the left hand limit and the right hand limit, right? And if they are equal, we say that limit does exist, and if they are not equal, we say that limit does not exist, correct? And third point is we are talking about indeterminate form. There are total 7 indeterminate forms, right? Out of them 4 are algebraic and 3 are exponentials, right? 4 algebraics are 0 by 0 form, infinity by infinity form, 0 into infinity form, and infinity minus infinity form, right? Why we say this as indeterminate form? We already have come across the concept, right? And the next is, before solving any question of limit, first of all we check the form of the limit, right? So this is the first and the foremost thing while solving the question, that you have to check the format, whether it is in determinate format or it is in indeterminate format. First of all we have to check before solving the questions, right? The fifth point is, in all the problems of limit, any value x is equals to a is not exact, it is always approximate, right? So somewhere if it is written that this value is equals to a, it means it is not equals to a, it is going to be a, right? For example, we had taken many times extending to 2, right? So it is not equals to 2, it is going to be equals to 2, right? It may be 2.0001 or it may be 1.9999 and so on, right? So the any value x is equals to a is always approximate, it is never exact value. Is it clear? Okay, next the sixth point is, we have talked about indeterminate form. Now we are going to talk about the determinate forms, right? There are some determinate forms also. It is not necessary that whenever you find the infinity term, it is going to give you indeterminate forms, right? So some determinate forms are infinity plus infinity, right? We are adding two infinite numbers, obviously it is going to give you a very big number, that is also infinity, right? If we are going to multiply them, right, infinity into infinity, a very large number into another very large number, it is also going to produce a very big number, that is infinity, right? So next, infinity raised to infinity, correct? So infinity, it's already a very big number, and raised to infinity, that is again going to give you infinity, correct? And 0 raised to infinity, what is 0? We are just going to learn about the 0 raised to infinity concept. 0, if you are talking about, as I said, in limit, whenever it is x is equals to a, it is not exact value, it is approximate value. So it is not exactly 0, it is 0.00000 and so on 1. This may be in plus or this may be in minus, right? And I am taking a raised to infinity. Now think about this, if the exponent on this number, whether it is positive or negative, if the exponent will tends to infinity, it will always tends to 0, correct? So this is going to be equals to 0, right? Next, we have taken some examples. 2 raised to infinity, 2 is a number that is greater than 1. So we already know the concept, when we take the base greater than 1 and we increase the power, the value increases, right? So if we are going to take the power infinity, it will obviously give you infinity, right? And 1 by 2 raised to infinity, so the number here is less than 1, right? So this is a number between 0 to 1, correct? 0 to 1. So when the base is from 0 to 1 and we increase the exponent, it is always tending to 0, right? So it will give you 0 at infinity, correct? So actually it will tends to 0 at infinity, right? Okay, next, this is 2 by 5 raised to infinity and 5 by 2 raised to infinity. How this works? 2 by 5 is a number that is from 0 to 1, so raised to infinity, that will gives you 0, right? And 5 by 2 is a number that is greater than 1, so if we will take infinity power, it is going to give you infinity, right? So 0, and this is minus infinity, that is result is minus infinity. And e raised to minus infinity, what about this? So e, what is e? E is a number, right, whose value is 2.7182, right? So if we are taking the power minus infinity, right, means what? This is 1 upon 2.7182 raised to infinity. So what is this? This is a number greater than, this is a number greater than 1. So if we are taking any number greater than 1 and raised to infinity, that is going to give you infinity, and 1 by infinity, we already know this is 0, right? So that is why this is 0, right? So after these discussions, so in general we can write limit x tends to a raised to x, right? This is a raised to x is equals to, it will be 0 when the base a is from 0 to 1, right? And it is going to be 1 when it is exactly equals to 1, right? And it is infinity when the base is going to be greater than 1. Is it clear? Next, some more concepts are there that we have to keep in mind always. These points you have to keep in mind in order to optimize the mistakes while solving the questions, right? What are these things? Exactly 0. We are taking exactly 0. It's not tending to 0, right? We are taking a number that is exactly 0 upon a number that is tending to 0, right? So 0 upon anything, that is always going to give you 0, right? And now any finite quantity, suppose we are taking 2 and by 0, you know this is going to give you infinity, right? Now any finite number by infinity, okay, again I'm taking at 2 by infinity, this is 0. Next, we are taking some examples here. Limit x tends to infinity sin x by x, and limit x tends to infinity sin square x by x. What will be the result? We have to see this. So before going to solve any limit, what we have to do basically, first of all we need to check the format. Read point number 4. Before solving the question of limit, first of all check the format of the limit, right? So what is the format of this limit? If we are putting infinity here, right, so this gives you sine infinity and divided by infinity. What is the value of sine infinity, right? What is the value of sine infinity? We all knows that the domain of sine is all real numbers, right? So it will exist at infinity also, correct? But what is the range of sine? It is from -1 to +1. So this is going to produce a number k that will always from -1 to +1, right? -1 to +1 and divided by infinity. So any number k by infinity, that is equals to 0, right? So its value is 0. So next we are coming on sin square x by x when limit x tends to infinity, right? As sin x lie from -1 to 1, so sin square x will lie from 0 to 1, right? It must be clear, right? So it will gives you a value that is from 0 to 1 and upon infinity. So any value between 0 to 1 upon infinity, that is also going to give you a 0, right? Okay, so the next point, 8th point, is how to calculate limit x tends to a f of x, right? So whenever we come across the question to find out the limit, first of all we need to check the function, the format of the function, right? First of all we have to find f of a, right? So the first thing will be, we will have to find out the value of f of a, right? Now f of a can be in two form, right? It may be determinate or it may be indeterminate, right? So when it is in determinate form, we have to find then left hand limit and the right hand limit, correct? Once we find LHL and RHL, then we have to check for the value of LHL and RHL to be equal or not equal, right? If they are equal, then we say that limit exists, and if they are not equal, then we say that limit does not exist, right? So this is the thing that we have to do when f of a is determinate, and when f of a is indeterminate, then what we have to do, then we have to go for the method of evaluation of limits that we have to study in the further part of the limit, right? So now I am going to solve some more questions that is based on the basic concepts of the limit, and at the same time I will give you an assignment that you have to solve your own. So coming on the next session of solving problems on the basics of the limits. Okay, so starting with some more basic and tricky questions. The first question is limit extends to infinity tan inverse of x, right? So as everyone knows about the domain and the range of this tan inverse x, right? So when x will tends to infinity, common sense, tan inverse x will tends to pi by 2, right? So can we say that the greatest integer of pi by 2, that is going to be is equals to 1, correct? So that's the answer, right? Next, question number second. Next is tan inverse of x when x is tending to minus infinity, right? So what about this thing, right? So when x will tends to infinity, minus infinity, tan inverse of x will obviously tends to minus pi by 2, right? So greatest integer of minus pi by 2, that is greatest integer of minus 3.14 by 2. 3.14 by 2 means minus 1.57, that is equals to minus 2. So that's the answer, right? So basically what you have to keep in mind before solving these questions, right, that the domain and the range of the function, right? The next question is limit extends to 0 plus tan x by x, right? In the last lecture I had said this thing, limit x tends to 0 tan x by x, that is equals to 1.00 है ना, 00 and 1, right? So this is a number that is slightly greater than 1, that is 1 plus, right? So can we directly write here 1 plus greatest integer, right? So greatest integer of 1 plus is going to be 1, right? So now here if we have written 0, it means 0 plus or 0 minus, it can be anything, right? So whether it is 0 plus or it is 0 minus, its answer is always going to be greatest integer of 1 plus. So greatest integer of 1 plus, that is a number that is slightly greater than 1, is equals to 1 always, right? Coming on the next question. The next question is limit x tends to 1 sine inverse of x, right? If you have studied about the inverse trigonometric functions, then you must be knowing that a sine inverse of x, that is equals to x, and here the domain is from minus 1 to plus 1, right? So the domain is from minus 1 to plus 1 and its range is also going to be from minus 1 to plus 1, right? Its range is also from minus 1 to plus 1. Now here the limit is x tending to 1. So can we find out the limit x tends to 1 minus first of all 1 minus sine inverse of x. So its value is going to be greatest integer of 1 minus, right? So its value is equals to 0, right? Because we have to find out the greatest integer of a value that is slightly less than 1, right? Like this 0.999 ye wali cheez, right? So its value is 0. Now next, can we find limit x tends to 1 plus sine inverse x? Yes or no? The question is yes or no, right? So first of all we have to check its domain, right? Is it going ahead of a, right? No, it's not going ahead of a. So 1 plus, right? So at 1 plus the function does not exist. The function does not exist, correct? If the function does not exist, it means the function is not defined here, so we cannot find its value, है ना? Can't be find, right? So it cannot be find. So if they are asking you limit x tends to 1 sine inverse x, means basically they just want to ask you limit x tends to 1 minus sine inverse of sine x, right? So if you will try to find this, you will not be able to find the thing because this is undefined for the 1 plus, right? Next question is limit x tends to pi by 2 sine inverse of sine x. Again we have to define it, since sine inverse of sine x is equals to x. Again in inverse trigonometric functions we have studied this thing, right? Sine inverse of sine x is equals to x, but here the x is from minus pi by 2 to plus pi by 2. At which value we have to check the limit? It is at pi by 2, right? So again we have to check for both limit x tends to pi by 2 minus, and this is a sine inverse of sine x, correct? So if sine inverse of sine x is equals to x and its domain is this thing, means its range is also going to be the same thing, right? What is its range? Range is also is equals to from minus pi by 2 to plus pi by 2, correct? So minus pi by 2 to plus pi by 2, if and we are finding out the limit x tends to pi by 2 minus. So this is what greatest integer of pi by 2 minus means 1.57 सी छोटी वाली चीज, राइट, माइनस इसका ग्रेटेस्ट इंटीजर. सो द ग्रेटेस्ट इंटीजर ऑफ दिस थिंग इज गोइंग टू बी 1, राइट. नाउ नेक्स्ट क्वेश्चन इज, कैन यू फाइंड आउट लिमिट x टेंड्स टू pi by 2 plus here, right, for sine inverse of sin x? We can find this or not? Again, since the domain is from minus pi by 2 plus pi by 2 only, right, so this is again not defined. The function does not exist for the pi by 2 plus, right, so this cannot be determined, this cannot be found, right. So that's the answer, right. So in these two questions, if they're asking limit x tends to 1 sine of sine inverse x, means basically they just want to check whether you are knowing the concept of inverse trigonometric functions or not, right. So we cannot find this at 1 plus. Similarly, in the same way, we cannot find this limit at pi by 2 plus, because the domain is from here, it is before 1 or equals to 1, and here the domain is less than equals to pi by 2. So we cannot go on the next value of the pi by 2 or on 1. Clear? Coming on the next question. The next question is limit x tends to 0 sine of mod of x by x, and this is the greatest integer of the function, right. So let's see about the solution of this question. First of all, we have to check for 0 plus and 0 minus, means we have to find out left hand limit and right hand limit. Left hand limit is what? Limit x tends to 0 minus, right. Why we are finding out left hand limit and right hand limit here separately? Because this is inside the modulus, right, and modulus changes for less than 0 and greater than 0 value, right. So 0 minus sine of mod of x and divided by x, right, greatest integer. So can you write this limit x tends to 0 minus? Okay, if this is 0 minus, can we say that this modulus will open with the negative sign, right. So can we write down sine of minus x and by x, right, by the definition of modulus. So this is what? Limit x tends to 0 minus, this is minus sine x by x, correct. So what is limit x tends to 0 sine x by x? That is 0.999, right. I already had discussed limit x tends to 0 sine x by x is always equals to 0.99999, right. So whether it is plus or minus, right, for both. So this is nothing but limit x tends to 0 minus, this is thing minus 0.9999 and so on. So what is the greatest integer value of, है ना? We can erase this also, right, because we have written the limit of this, right. So what is going to be the greatest integer of this number? This is equals to minus 1, right. Now we are finding out the right hand limit. What about right hand limit? Right hand limit means this is limit x tends to 0 plus greatest integer of sine mod x by x. Since this is 0 plus means positive, so it will open with positive sign. So this is nothing but limit x tends to 0 plus sine of x by x, greatest integer, and the value of this when limit x tends to 0 is nothing but 0.9999 and so on, right. So its value is going to be 0 because this is positive, right. So here we can say that left hand limit not is equals to right hand limit, therefore limit does not exist. Clear? Next, now I am going to give you some questions in the assignment that you have to solve your own at your home, right. So try these questions. These are very simple and tricky questions. Again I am saying, right, there is no questions that is going to be very tough for you guys, right. So the assignment will be displayed over here. You just try it once, right, okay. And try to solve all the questions one by one. If you come across any kind of difficulty, just you can text me in the comment box on my channel. So students, this is the assignment for you all. Just try to solve all the questions one by one, and options for the some questions are given over here. While solving these questions, if you find any difficulty, just post your difficulty in the comment box on my channel. I will be there to answer you, right. And now I am concluding this session of today with this assignment, and in the next lecture we are going to discuss with the evaluation of limits, right. And you can also share this video with your friends so that they can also get benefit from this video. And please give your feedback in the comment box for every lecture that I post on my channel. Keep watching, keep learning, stay home, stay safe. Thank you. Thanks a lot.